In this video, we're going to take the derivative of a function which is exponential and also includes some trigonometry and a product. So we'll begin by looking at the function. We've got y equals e to the theta times sine theta plus cosine theta. So the first thing we notice is we have a product here. We're going to use our product rule. So the derivative of y with respect to theta, make sure you pay attention to your independent variable, would be first e to the theta times the derivative with respect to theta of sine theta plus cosine theta plus sine theta plus cosine theta times the derivative with respect to theta of e to the theta. So we've used our product rule to apply how the derivative is going to be spread out, and now we have two basic derivatives to calculate. So e to the theta will remain e to the theta. There's nothing to do there. The derivative of sine theta is cosine theta, and the derivative of cosine theta is negative sine theta. Plus, we have sine theta cosine theta times the derivative of e to the theta, and the derivative of e to the theta is e to the theta. We don't need to use the chain rule here because that exponent is just one variable. Even if we did, though, the derivative of theta with respect to theta, that would just be times 1, right? So the chain rule is always embedded in the problem. It's just we don't always have to use it or see it because that derivative would be 1. At this point, I'm going to distribute e to the theta times both of these terms and e to the theta times both of the other sine and cosine terms. So that gives me e theta cosine theta minus e theta sine theta plus e theta sine theta plus e theta cosine theta. So you should notice that our two middle terms are opposite each other and they're going to cancel each other out. And then the first and the last term are the same. And if we have 1 and 1 of each of those, my derivative here would be 2 e to the theta cosine theta. That represents the derivative of my original function.